Good morning everyone, welcome back to Coding Hives. In today's video, we are going to understand one of the most important concepts in coding interviews and competitive programming, that is dynamic programming or DP. So by the end of this video, you will understand what is meant by DP and you will learn the two main ways to solve DP problems. They are memorization and tabulation, and then we will try to solve two LeetCode problems using this method. So what is meant by this dynamic programming? Imagine you are solving a big problem, and while solving it you realize you are solving the same smaller problems again and again. So dynamic programming helps us to avoid that repetition by storing the results of these small problems and reusing them. There are two main things we check before using DP. That is overlapping subproblem. That means, are we solving the same smaller problems multiple times? And the next question, you need to check optimal substructure. That means, can we build the final solution by combining the answers to smaller subproblems? If both the answers are true, then we can use DP to solve the problem in an efficient way. There are two main ways to solve this DP. They are memorization and tabulation. Memorization is a top-down approach and tabulation is a bottom-up approach. But before starting this, we will understand the problem of the normal routine. For understanding both of this method, first I will explain Fibonacci series and what is the problem of that normal coding. I mean without DP, what is the problem? Then we will try to solve the same problem using these two methods. I mean this memorization and tabulation. So what is mean by this Fibonacci series? I believe you know this, like the series of 0, 1, then 1, 2, 3, then 5, and so on. So that means this number is the sum of the previous two numbers. Okay. One statement is, we are given a number n. We need to return the nth Fibonacci number. For example, you know now Fibonacci 0. I mean 0th Fibonacci number is 0, right? Now 0th Fibonacci number is 0. Like that, first Fibonacci number is 1. Then second is 1. Third is 2. Right? Fib of 1 equal to 1. Fib of 2 equal to 1. Fib of 3 equal to 2. Fib of 4 equal to 3. And fib of 5 equal to 5. Right? So normal recursive approach, I mean the brute force approach, we will write the problem something like this. Like simply I will write here like def fib of n, right? So this is the Fibonacci function and n is the, I want to return nth Fibonacci number, right? So n is that number. So here what I'm going to do first is I will check if n is less than or equal to n. That is the base condition, right? If that is the true, then we can simply return that n, right? So I will return n. This is the base condition. Otherwise we need to again recursively call the function, right? We can call this function as return fib of n minus 1 plus fib of n minus 2, right? Like this we will call the function. So here the problem is, for example, if I am giving the value n as 5, so I want to return fifth Fibonacci number. Okay, so in this case, how this execution is happening is, we can write something like this: Fibonacci of 5, right? Like Fibonacci of 5 we need to calculate. I mean the function will call fib of 5, right? So then what is going to happen is fib of 5 is, it will return fib of 4 plus fib of 3, right? So here something like this, like fib of 4, so then again recursively calling the function with this fib of 4 and fib of 3, right? Fib of 4 equal to fib of 3 plus fib of 2, right? This is fib of 4, right? Now fib of 3 we can calculate as fib of 2 plus fib of 1, right? So you can see like some functions are calling multiple times, right? Now fib of 2 we can calculate something like fib of 1 plus fib of 0, right? Here you noticed that we are calling fib of 3 here multiple times, right? Also fib of 2 here multiple times, and also here fib of 1 multiple times, right? So fib of 2 is calculated multiple times, fib of 3 also calculated multiple times, right? So this wastes time and makes the program slow, especially when n is large, okay? So we can avoid these problems by using this DP method. So I hope you understand the problem in the normal approach, right? So here we are calculating the same values multiple times. That is the problem. So first I will explain the first method in DP, that is memorization. So memorization is like a recursion with memory, okay? So we solve the problem using recursion, and whenever we solve a sub-problem, we store its result in memory structure like a dictionary to reuse it later. So this way we can avoid solving the same sub-problem multiple times. So here the problem is LeetCode problem number 509 using Fibonacci number. I will use a dictionary. For example, I can use a dictionary named Memo. Okay, and here I will check the base condition, like if n less than or equal to 1, that means we can simply return n, right? Otherwise, what we need to do is we will check if that n is in this dictionary. Okay, then we no need to calculate again, right? So here we can check something like this. If n in memo, then we can simply return memo of n. Okay. Otherwise, we can calculate this memo of n is equal to fib of, like this. We can previous two numbers, right? So we can use fib of n minus 1. Also, we need to pass this memo plus fib of n minus 2, then this memo. Okay. And at the end, we can write something like return memo of n. Okay. Now we will run this code. Yeah, I missed R. Yeah, the problem is here I can write, I need to write self. Okay, we'll check that. I think so. Run. Yeah, then submit. So the complexity will be order of n, right? Yeah, order of n. So here, if you call fib of 5, it will first check if fib of 5 is in memo, right? So here, if you call fib of 5, it will first check if fib of 5 is in the memo dictionary, and it is not, it will calculate fib of 5 by calculating fib of 4 and fib of 3, right? So now calculate fib of 4, it calls fib of 3 and fib of 2, right? So it will call fib of 3 and fib of 2. Again for fib of 2 it will call fib of 1 plus 0, right? So once fib of 0 is calculated, it will be stored here, okay? And here fib of 1 will be stored here. So fib of 2 will be stored here like this. These values will be, corresponding values will be stored in this memo dictionary. So if you call fib of 5, it will first check if fib of 5 is in this memo dictionary. So if it is not, it will calculate fib of 5 by calling this fib of 4 and fib of 3, right? So now to calculate fib of 4, it calls fib of 3 and fib of 2. And similarly for fib of 3, it calls fib 2 and fib 1. And for fib 2, it will call fib 1 and fib 0, right? So once this calculator, for example, fib 2 is calculated, it is saved in this memo dictionary. So the next time we need this fib of 2, it will directly return the saved value instead of recalculating this again, okay? So this process continues until we get the final value for this fib of 5, I mean n equal to 5. Clear? So this memorization technique helps us to avoid repeated calculations by storing already computed results. This makes the recursive solution efficient. So now we will understand the next method, that is tabulation method. That is a bottom-up approach. In tabulation method, instead of using recursion, we start from the smallest subproblem and solve each subproblem iteratively while storing the intermediate results in a table, for example, an array. This is called a bottom-up approach. So here also we will use the same Fibonacci problem to understand this method. We will first initialize an array where we will hold the Fibonacci numbers, okay? And also we will set a base case. This also. So here what I'm going to do is, the base case is there the same, like if n less than or equal to 1, that means that is a base case, we can simply return the n, okay? Otherwise what we need to go do is, we will make a list like dp, and I will make an empty list, not an empty list. I will make a list of elements 0, okay? First I will create a list. Here I can create something like this. So this will create n elements with a 0, okay? And so here we need the first Fibonacci number is 0, we know that, right? And the second one will be 1. So I can do something like this, dp of 1 equal to 1, okay? Clear? Now we need to make a list of Fibonacci numbers. So for that I can write, for I in a range of, we need from 2 only, right? We know 0 is 0 and 1 is 1, right? So we need to start from the second element. So for that I'm writing 2 comma n plus 1, okay? And here I can write dp of I equal to dp of I minus 1 plus dp of I minus 2, right? So this will add the previous two numbers and store in that corresponding position, okay? So if you want to return nth Fibonacci number, you can simply return dp of n, right? That's it. So now I will explain this code with an example. First we will run this. Syntax error. Every time I'm missing R. Yeah, we will submit this thing. So here we first initialize an array dp where dp of I will hold the ith Fibonacci number, right? So here the base case is, we know the 0th Fibonacci number is 0, right? So this is 0, and the first Fibonacci number is 1. Okay, that is these two lines. Okay, so when we start from I equal to 2 and use a loop to fill in the DP array, we can see something like this. DP of 2 equal to DP of 1 plus DP of 0, right? That means 1 plus 0, right? So our answer is 1. Clear? Now for the next one, that is DP of 3. DP of 3 is DP of 2 plus DP of 1, right? This DP of 2 is 1, DP of 1 is 1. So here this is 2. Okay, like this we will continue this until we calculate the desired DP of n. Okay, DP of 4 will be DP of 3 plus DP of 2, right? So here DP of 3 is 2, 2 plus 1, so it is 3. Okay, so like this the calculation is going on. So here this tabulation builds the solution from the bottom up. Okay, it uses a table to store intermediate results, making it an efficient way to solve DP problems. I hope you got a clarity about this problem.